Hello, and welcome to the instructions for the Determining Compound Solubility Lab. This is Lesson 2.03, Determining Compound Solubility Lab Activity. Here's the reference website right here. You can either copy and then right-click to paste, and then you can paste it into your URL tab, or you should just be able to hit Control-click and click on it. Our objectives are to determine whether a solution is unsaturated or saturated, and explain how compound solubility is determined at different temperatures. First thing you want to do is fill out the pre-lab. Let me click over to the website. So the pre-lab can be answered using this little section on the left side of the screen under where it says how is solubility of a compound determined. In a solution, the substance being dissolved is the solute. You'll notice right here it says, in a solution, the substance being dissolved is the, and then you would just fill in solute right there. And it looks like you might need to use solute twice, so it's listed here. I don't know, and same thing with solvent, I don't know that you'll necessarily use these all. I can't remember exactly, but do realize that you may use solute twice or solvent. And again, you can find that right on the website. Right here on the left side. All right, so moving right along here, hypothesis. So if ammonium chloride, barium hydroxide, copper sulfate, potassium chloride, and sodium nitrate are each dissolved in the same volume of water, then I expect they will each dissolve to blank extents. You'll either fill in the same or various. And here is the procedure right here. You'll repeat each of these procedure steps for each of the following compounds available in the virtual lab. So I'll show you guys just for the first one, ammonium chloride. You'll have to do this again for the other, I think there's 4 more. So this is the one we're going to start with. It's already selected. You could click on it and make it red to select the different ones, but you'll want to make sure NH4Cl is selected first. So choose 0 degrees Celsius on the hot plate. This is the hot plate right here. It's already at 0 degrees Celsius, so you really don't even need to click it, but just make sure in case, I don't know if it would be at a different one. So if you click it and it makes that noise, it just means it's already on 0 degrees. Choose one of the 5 compounds available by clicking the bottle. Once it has been selected, the label will turn red. Again, NH4Cl is already selected for you. If not, just click on it and it'll turn red. Or if it makes that noise, you know it's already been selected. Click on a scooper to dispense 1, 10, or 25 grams of the compound into the container of water. You will continue to add more of this compound at 0 degrees Celsius until you believe the saturation point has been reached within 1 gram. The counter on the virtual wall will keep track of how much compound you've added for each experiment. If you add too much, you'll see a solid salt on the bottom of the container, and you click undo and use a smaller scooper. So here's what I mean by that. So start with adding like 25 milligrams. And there's nothing at the bottom, so I'm going to add 25 more. See how that is at the bottom? That means you super saturated your solution, so I'm going to click undo. That'll take away the second 25 that I added, so that first 25 is still there. So it keeps track of how much you add right here. And then I'm going to use the 10 grams. Oh, so I see this. That means I super saturated my solution, so I'm going to click undo, and I'm going to go down to the 1 gram. And I'm going to add it until I get that buildup on the bottom. See, I got that buildup on the bottom. So what you want to do is click undo to get rid of that. So that means that at 30 grams, your solution is saturated, meaning it has dissolved as much as possible. If you add even 1 more gram, you're going to end up with some on the bottom, meaning that it's past its saturation point. So let me undo that again. So this 30 grams is what's going to go in this table right here. So it's 0 degrees Celsius for NH4Cl, 30 grams. So then after that, you'll do the same thing at 20 degrees Celsius.